Hi Atmadeep, how are you?
Sir, I'm fine, sir.
So Atmadeep, where are you from?
Sir, I am from Hooghly district in West Bengal.
And Atmadeep, how many questions were you able to do in UGB?
Sir, I was able to do 4 questions full in UGB but in one question, in those 4 questions, there was a slight silly mistake.
Okay. Did you have a chance to look at other questions that you were not able to do after the exam?
Yes, sir, I went through the other questions and their solutions.
Okay. Is there any question in the exam that you could have done differently now?
Yes, sir, the calculus question I would have done more genuine method.
Problem 8.
Yes, sir, probably.
No. So Atmadeep, what are your areas of interest?
So my main areas of interest are combinatorics and calculus.
Okay. So Atmadeep, imagine there to be a hexagon and there are numbers on each vertex. Let's say there's a number 1, 0, 1, 0, 0, 0 as of now, right? So basically, what you can do is you may increase the two neighboring numbers by 1. Increase at any step. Any step, any push would mean increase the two neighboring numbers by 1. The question is it possible to equalize all the numbers?
Okay, sir, can I do something in my exercise book?
Yeah, of course.
So this is the initial state.
Yes, this is the initial stage.
So we may do by using the invariance principle, sir. If I name the vertex as A1, A2, yes, sir, and then I will check the, uh, I will check the, sir, A1 plus A2 plus this sum. Summation of AI.
Mm.
Yes, sir. If in some step this is uh, equal, for sake of contradiction, if this is equal, then this S would be divisible by 6. 6k
Mm.
type. Yes, sir. Then, sir, the number of steps required will be, sir, 3k minus 1. Because, sir, initially the S equals to 2 and finally S equals to 6k, and in each step S is increasing by the number 2. Yes, sir. So
Mm.
the number of steps will be, so 3k minus 1. Then, sir, I will check another thing, that is, uh, summation of a1 minus a2, mod of a1 minus a2 plus mod of a2 minus a3. Yes, sir, with a mod in the difference. No, sir, no, sir. A1 minus a2, mod of a1 minus a2 plus mod of
Okay.
a2 minus a3. Sir, every adjacent pairs, difference between every adjacent pairs. There will be 6 pairs, sir, in my calculation, sir.
Okay.
Yes, sir.
Got it. Basically, you want to check this. Plus mod of A2 minus A3 plus mod of A3 minus A4.
Yes, sir. Yes, sir. I want to check this.
Okay. plus A6 minus A1.
Yes, sir.
Hmm.
Sir, now this sum can be of five types. That is, it may increase by plus one or plus two, or don't increase, or sir, minus one or minus two.
Minus 1. Can it be minus 1? Are you talking about S dash?
Yes, sir, I am.
Okay.
Sir, and if I take the sums like plus one A times, plus two B times, etc., then sir, there is a contradiction with modulus.
How is the contradiction? So what is this sum initially?
So this sum is initially sir 1 plus 1, so 4,
Hmm.
and finally sir 0.
Okay.
So
So
show
can't it
the
reach 0?
if yes sir. Sorry
Can't
sir.
it reach 0? Basically, if I
Sir, I
increase
think in
this,
3k minus 1 cases it can reach 0. It can reach 0. And after 3k
okay,
minus
and
1 cases, I am.
okay, and how do you prove this?
Sir, if I take the number of plus ones as B1, plus 2 as B2, etc., then,
Hmm.
sir, the thing is coming that A minus D plus 2 into B minus E equals to minus 4. And uh, A plus B plus C plus D plus E is coming, sir, at 3k minus 1. So, sir, I think I missed up.
But I think you're quite close to this. So instead of this, if you could, I just give you a hint. A1 minus A2 plus A3 minus A4 plus A5 minus A6. So what would be the final state of S double dash?
So it should be 0.
Final state.
Yes, sir.
Yes. And what is the initial state?
So 2.
It is 2. So 2 to 0 it has to come. And
Yes, sir.
every step that
Yes,
is
sir.
increasing the neighbors by 1, would it affect this?
Oh, actually, no, sir.
Okay, so this was a very simple. I mean, you're very close to this, right? But this was more on the simpler terms. Okay, but yes, good thought. Okay, so on the similar lines, I'll put another question. So let's say there is a hexagon, all heads, or let's make it an octagon. So let's say there is an octagon. Okay. So every corner there is a coin showing heads. My first question is, and I'll give you a situation first. So every move includes flipping two adjacent coins. Okay, so you can one move would be moving these two coins tails. The second move can be this is tail, this can be head, and this can be tail, and so on. So every two adjacent coins to be flipped, this is one move. My first question is, after six moves, is it possible to attain HT, 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 HT orientation.
Sir,
Yes, no.
sir, if I assign +1 for H and 0 for T,
HS.
sir, H as 1 and T for 0.
Okay.
Then, sir, my initial sum is 0. And, sir, uh, in each move, either it is going +2 or -2 or 0. So, sir, after 6 moves, it will go something like A minus B into 2, where I mean the sum will go A minus B into 2, where A is the number of plus 2 moves and B is the number of minus 2 moves and C is the number of, say, 0 moves. So A minus B into 2 will come 4 if this orientation is possible. So, sir, A minus B equals to 2 and A plus B plus C equals to 6. So A minus B equals to 2, the probabilities are 2, 0, 3, 1, and I think 4, so the thing will go like
So it is
2,
possible.
0. Uh, sir, yes, sir, I think it is
So
possible.
one thing that you're not taking into account is, okay, so basically you're saying here that there will be 4 tails possible, but would it be in this orientation is the question. So again, this clearly shows that there could be 4 tails possible after 6 moves, because this and this is going to have definitely integral, non-negative integral solutions are going to be there for these two equations. But would it be HT, 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 HT orientation?
Sir, if I take some other sum, that is, sir, A1 into A2 plus A2 into A3, I mean, sir, A1 represents the first vertices.
Okay.
So, sir, if I take A1 into A2 plus A2 into A3, and no, sir, this will not.
Okay. So let me give you a hint. But this is a good thought. But again, this misses the point that whether HT, HT will be alternates. So again, definitely, if after 6 moves there are 4 T's and 4 H's in any order, this is possible by your this thing, right? Now, let us imagine there are 8 buttons in between the two vertices. So again, pushing a button would mean flipping the 2 coins which are adjacent to that button. Right. So basically, overall, we have to press 6 buttons. Right. And after 6 buttons, we have to see whether it is possible to have this orientation. Also, this coin will be affected by these 2 buttons. Right. So basically, total number of pushes on these 2 buttons. If this has to be head, let's say final position, I want HT, 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 and HT. If this remains head, so what would be the parity of the sum of the pushes on these 2 buttons?
0. I mean, even.
It is going to be even. So this plus this should be even. What about this plus this?
So this should be on.
This should be odd. Right. So let us start with anything. So let's say this is odd. There are odd number of pushes on this button. So what would be the parity on this button if the final head is to be head?
So also on.
Odd. Okay. What about this?
So this should be even.
What about this?
So this should be also even.
Any move? Now this.
So odd, then again odd, then even, and then
So
so on.
basically, basically, if I want this orientation HT, 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 so I have to push this button or any button in any cyclic order odd number of times. If this is odd, even, even, odd, even, even.
Yes, sir.
Right. Okay.
Yes, sir.
Now, odd means how many pushes? Odd means either 1, 3, 5, or 7 pushes.
Yes,
Even
sir.
means 0 to 4 and 6 pushes.
Of course.
Now tell me, is it possible or not?
Sir, if I assign 1 to all odd places, and 2
Okay.
to 1 even and 0 to all other even.
So 1 to these 4 and
So 2 to 1 even
2 to
and
any
0
one of
for
the
all other.
events.
Yes, sir.
Perfect.
And 0 for
So
all
this
other.
would be one orientation.
Yes.
Perfect. Is there any other thing that you can do?
Sir, if I go for one, sir, if I go for odds like 1, 3, 1, 1 and 0 for all even places.
Perfect. Then also it is possible.
Yes, sir.
So all events 0. Perfect. Right. So of course, ST is definitely possible, and we've proved this. Now my question is, how many different sequences of moves is going to give me ST?
So can you
Yeah.
repeat the question once?
So the question is, how many different sequences of these 6 moves is going to give me ST?
So, sir, for the first case, that is assigned 1 in every odd and assigned 2 in at exactly 1 even. So that, sir, there are 4 places of even in a cyclic permutation order, and I have to choose one option for 2. So that can happen in exactly, sir, one case. I mean, that can exactly happen in one fashion because sir, every even positions are symmetric to the uh, I mean
Okay, forget
orientation
about
of
symmetry.
all.
Forget about symmetry.
So if
The
the
I,
vertices are numbered differently.
yeah. So imagine the vertices to be numbered.
Okay, so
Let's say
then sir for
numbers
the
are A1,
first
A2,
case,
A3. Yeah.
yes, sir. Then sir for the first case there are 4 cases possible, and for the sir, second case we have 4 more cases possible because we should assign 3 in one of the odd buttons and then 1 at all other buttons. So sir, total cases are 8.
Okay. Now, if I also take into account which button is pushed first, which button is pushed second. For example, in the first case, these are so total of 6 buttons, 1, 1, 1, 1, and 2. So which button is pushed first? This also matters.
For the first case, that is uh, 1, 1, 1, 1, and 2, and 0 at all other places. So there we will choose 62 times when for each orientation. I mean, for each sequence, I choose 62 ways to when to push the even button. And for answer all other 4 cases, there are 4 factorial ways. So, sir, the first in the first case, there is 62 means 15 into 4 factorial into 4 for the number of cases. And for the
Perfect.
second same session into 2. So, sir, my final answer is so 2880 is my final answer.
Perfect, Atmadeep. We are ending the discussion here.
Thank you, sir.
So overall, amazing discussion. Uh, and there is no feedback. And I keep on giving feedback to other students also. But for you, there is no feedback. I'm more than confident that you'll be able to make it right. So there's no feedback from my side.
Thank you, sir.
You're I mean you're good. Uh, just the only thing is keep smiling in between the interviews. Right. So
Yes, sir.
otherwise, as far as mathematics content is concerned, I don't think there is any issue whatsoever. The questions I mean, इतने tricky questions भी नहीं पूछेंगे वो. But they normally ask, you must have seen on Quora and other things, they ask very simple questions, very, but seeing your marks, they might, raise their uh, level because you've done 4 questions correct. And UGA, how many marks you got?
Sir, 104.
Yeah, so seeing that, they might increase the level, but again, that should be a no issue for you.
Sir, actually, my marks is not so fancy because I know 10 more people at least who have got more marks than me. So, sir, that is
Yeah,
not
that
okay.
is that is fine, but again, you're going to do really well in the interview. This is what I know. I just keep smiling. That is the only feedback. Uh, so during the
Sir,
interview, just keep.
I have a small doubt about the UGB paper because they might ask the UGB solutions, the
Hmm,
questions which I have been answered. Sir, in the question 7, where the recursion, sir, the roots of a cubic equation alpha, beta, gamma were given, and the recursion was said that alpha power n plus beta power n plus gamma power n. And we
hmm,
had to prove that this is a polynomial on alpha, beta, gamma.
hmm.
So, sir, my question is, sir, according to the solution by Chetan sir in the YouTube, sir, sir have proved that it can be written as some, I think, uh, in some algebraic form, that is a into something plus b into something in that manner, and so it is a polynomial. But my sir, what I have understood reading the question is that I have to prove a n equals to p of n, sir. This is a confusion. I can actually find the actual meaning of the question.
To prove that xn plus yn plus zn can be written as polynomial with integral coefficients in the
Yes, sir.
variables alpha, beta, and gamma. This is what you're talking about.
Yes, sir. Yes.
Okay. And what are you saying?
Sir, I'm saying that the in the solution, Chetan sir has proved that this xn plus yn plus zn can be written in some form of alpha, beta, gamma by proving the recursion. This follows, and because
Hmm,
the base cases are some algebraic expression of alpha, beta, and gamma, so the higher cases will also be the same. So this
hmm,
is what sir has proven. But
hmm.
sir, does that says a polynomial, sir? That is my question because there is no uh, px type expression.
Okay, I'll probably have a look at it, Atmadeep, in detail, and we'll get back to you by evening.